So far, our C code can calculate using arithmetic operators like plus sign and store data using assignment operators like equal sign, but our program still runs like a recipe. Step 1, then step 2, then step 3, running straight to the end. Cannot make choices. It cannot decide if the user's score is greater than 100, then display a level up message. To introduce logic and enable decision-making, we need operators that can ask questions. We need comparison operators. Welcome to Lesson 2.06. Today, we master comparison operators, also known as relational operators. These operators allow your program to compare two values and determine the relationship between them. The result of every comparison operator is always a simple, binary answer: true, 1, or false, 0. We will cover the four most essential comparison operators: less than, greater than, is equal to, is not equal to, first, less than, and greater than. These operators are exactly what you remember from basic math. They check if one value is smaller or larger than another. Let's declare integer a equals 10 and integer b equals 20. Example 1. Less than integer result 1 equals a is less than b. Is 10 less than 20? Yes. In C, the result stored in result 1 will be 1, true. Example 2. Greater than integer result 2 equals b is greater than 30. Is 20 greater than 30? No. The result stored in result 2 will be 0, false. The related operators less than or equal to and greater than or equal to are simply combinations of the basic operators. Second, the critical trap is equal to. This is arguably the most common mistake for new C programmers. To check if two values are equal, we must use two equal signs. This is the comparison operator. Example: integer result 3 equals 10 is equal to 10. Is 10 equal to 10? Yes. Result is 1, true. What happens if you use the wrong one? If you accidentally write if score equals 100, instead of if score is equal to 100, the compiler will not give you an error. Instead, the assignment operator will assign the value 100 to score. In C, any non-zero value is treated as true, so your condition will always evaluate to true, creating a bug that is incredibly difficult to track down. Rule: always use double equals for comparison. Third is not equal to. The opposite of equality is inequality, denoted by the exclamation mark followed by the equal sign. Integer result 4 equals 5 is not equal to 10. Is 5 not equal to 10? Yes. Result is 1, true. Integer result 5 equals 10 is not equal to 10. Is 10 not equal to 10? No. Result is 0, false. Fourth, the output true is 1, false is 0. In C, the results of these comparisons are stored as simple integers. True is always represented by the integer value 1. False is always represented by the integer value 0. In conditional statements, any non-zero value is treated as true. But for comparison operators, the standard true result is 1. You now know how to ask simple questions. Is A greater than B? Or is C equal to D? But what if you need to ask a compound question? Like, is the score greater than 100 and is the game still running? To combine or negate multiple simple questions into complex logic, we need the final set of operators, logical operators. Click on the next video to watch Lesson 2.07. Operators, logical operators, where we will learn how to use and not to build complex decision structures.